Okay, in this video we are going to look at the area and in some cases the perimeter or the degrees for particular angles in polygons. We are going to start with this right angle triangle where we are going to find the area. We know that the area of a triangle is equal to half base times height. It is pretty straightforward, so all we do is to substitute and simplify. My base, in this case, 10 units, and my height is 24. Half of 10 is 5. 5 multiplied by 24 is 120 units square. Any question there? Thank you. Let us look at a word problem. In this question, we want to find the area of a square that has side 14 cm. Because it is a square, we immediately know one thing. Whatever one side is, exactly the same will be for the other 3 sides. So all 4 sides must show a length of 14 cm. The area of a square is S square. So it will be 14 multiplied by 14. Okay? Our working area, 14 by 14. 4 multiplied by 4 is 16. 4 multiplied by 1 is 4, plus 1 is 5. So we move into the tens line now. So we add a 0. 1 multiplied by 4. 1 multiplied by 1. And then we find the sum of these two. 6 plus 0, 6. 5 plus 4, 9. And 1 plus 0 is 1. So the area of this square is 196 units square, right? 14 by 14, 196. Let us look at another question. Okay? We want to look at this rhombus. The area of the rhombus above is 80 mm square. Find the length of diagonal number 2. So we know what is one of the diagonals. We know what the area is, but we do not know what the other diagonal is. That is our unknown. But let us look at the formula that is used to find the area of a rhombus. We may use diagonal 1 multiplied by diagonal 2 over 2, or we may say half of diagonal 1 multiplied by diagonal 2. A is my area. I am now going to substitute. I was given 80 mm square. That's my area. Okay? I was given 80 mm. I am going to substitute this piece as well. Now, my D1, diagonal 1, is 16 mm. So I substitute. But my diagonal 2, I do not know my diagonal 2. That is my unknown. So I will write D2. And let me simplify this line. 80 mm squared. Half multiplied by 16 is 8 mm, and my unknown is D2. We've looked at a similar problem earlier in another video, whereby we have one unknown and we treat it the same way we will solve a linear equation, where we work to keep the unknown by itself on one side. My unknown is D2, that is my diagonal 2. Therefore, I want to remove 8 mm. And the logical way to remove 8 mm is to divide both sides by 8 mm. M goes with M. 8 into itself is 1. Let us look over here. 8 into itself is 1. 8 goes into 80 exactly 8 times. MM will go with the square, so we'll have MM remaining. Right? 8 into itself is 1. 8 into 80 exactly 10 times. Alright? So 10 mm is equal to D2. 10 mm is equal to D2. So my diagonal 2 up here, I now found a value. So this diagonal is 10 mm. We can use either of the formula. I decided to use the second one, half D1, D2, and then I substituted here. 80 mm squared is equal to half times 16 mm times D2. Half by 16 is 8 mm. Once we remove the 8 mm, 8 into itself 1, 8 into 80, 10. So my unknown is 10 mm. Let us look at another word problem. We want to find the area of a square with a side length 12x cm. Again, we've looked at a square earlier with 14 units. In this case, it's gonna be 12x cm. We know that area of a square is a square. So it will be 12x cm multiplied by 12x cm. 12 multiplied by 12 is 144. X multiplied by x is x squared. Cm multiplied by cm is cm squared. 144 cm squared. That is the length. Okay? You may review at any point. We are going to look at another one. In this case, we want to find the area of the rectangle that has a width A inches and a length that is triple the width. So I'm gonna do my little sketch of my rectangle. Width A inches, and then length is 3 times, so it will be 3A inches. All right, area of a rectangle. Length by width, and I substitute A inches multiplied by 3A inches. A by 3A, 3A square, INCHES inches square. So it will be 3A square inches square. We are going to look at another word problem. In this case, we want to find the area of the circle. And this circle has a radius of 5 feet. Okay? And so if I'm to look at a little sketch of what that will look like, I can have something looking like this, right? Okay, now they did not tell us what to use as our radius. Radius as the pi. We have our radius of 5 feet. Pi could be 3.142. It could be 3.14. and it can be 22/7. In this problem, I'm going to use the 3.142. Okay? Area of a circle is pi r squared. My pi is 3.142. My radius is 5 feet times 5 feet. Okay? And I'm going to simplify. I'm going to simplify in this way. Good. I'm going to multiply 3.142 by 5, and then I will multiply by 5 again. 3.142 multiply by 5. Good. 5 2s, that's gonna give me 10. 5 4s are 20 plus 1, 21. 5 1s are 5 plus 2, 7. 5 3s are 15. And I once again multiply this by 5. Okay? So let's go. 5 times 0, 0. 5 1s, 5. 5 7s, 35. 5 5s are 25. And 3, 28. 5 1s are 5 plus 2, 7. So this gives me 78.550. But I was asked to round my answer to the nearest 100. So if I'm to round to the nearest 100, I will write 78.55. Now, it depends on which of the pi you use. Okay? If I use 3.14, I'm not going to get this exact same answer. But approximation, my answer will be the same. But it's not going to be exactly what we see here. Good? Let us look at another question. Okay. Another word problem for us. Find the circumference of the circle that has a radius of 5 feet. Having found the circumference, we are then required to round our answer to the nearest 100. Again, we can find circumference using two different formulas. We can use pi d or 2 pi r. Alright? So if I'm to use pi d, I will have to double my radius because the diameter is equal to twice the radius, okay? And in this case, I'm going to use my same pi as 3.142. So if my radius is 5, my diameter will be 10. And this is very straightforward to do because I'm multiplying by 10. I start at a point and I make one move to the right. So one move to the right will give me 31.42. Okay? So that will be my circumference, rounded to the nearest 100. Let us look at another question. It's another word problem. We would like to find the measure. I'm not going to use this octagon. Find the measure of the central angle of a regular octagon. Now here is my octagon. Okay? To find the measure of a central angle of a regular octagon, what we can do, identify our center. Okay? And at each vertex, if we want to, right? We may draw a line. Good. So this is my rough sketch. We know that this center can be represented by a circle. And a circle has a total number of degrees. A circle is equal to 360 degrees. Octagons carry 8 sides, right? So this octagon has 8 sides. Since I know it has 8 sides, they're equally divided. I can quickly divide 360 by 8. And when we divide 360 by 8, we will get exactly. Therefore, the measure of the central angle, each angle of a regular octagon is exactly 45 degrees. Okay? In the next video, we are going to target these two questions. See them? 1 and 2. Okay? So you may attempt them, keep your answer, and then we are going to compare when we get there. Alright? So we end there for now. Thank you. You may include any question, concern, or query that you have.